thanks for coming, and thank you very much for this opportunity to speak. It's great to be here and to build bridges in Taiwan. There's a lot of work going on across the world in collaboration around free and open source software, but it's still relatively new for us to be communicating effectively with Taiwanese institutes and businesses. So today, for me, is a great opportunity. I'll explain a little bit about myself. Basically, I meddle in corporate communications. I'm part of the communication infrastructure that's appearing to support free and open source software around the world. I hold various titles. Some of them are connected with non-profit organizations, such as my work as Senior Advisor of Free Software Foundation Europe, and my work as Asia Representative of Open Forum Europe, a policy organization based in Brussels. Some of my titles are corporate, such as my work as Regional Director Asia of the Open Invention Network, and my own company's work, Open Dawn, in communications and security. What I do, quite simply, is deal with how we use software today and help people improve their own use of software. Inevitably, this is about how free and open source software works and why it works, and how we understand that and apply it to the real world. So, what is this? Everyone has heard of it by now. You simply cannot be involved in technology without hearing the words free software or open source. It just won't happen. If you do anything involved with code, you will meet it because it's now everywhere. Free and open source software is an approach to software. It's an approach to software that has become extremely popular. It's become so popular, in fact, that it's creating multiple perspectives of what it means to businesses, to society, and to individuals. For this reason, it can be a little bit confusing. What we're going to do today is to look at the basic principles of what this approach to technology is, look at why those principles are important, and how they apply to the real world. The idea is to take a step back, to create context, and to allow us to frame this field in such a way that we can understand it and apply it to our own context, whether we're doing teaching, research, or business. What we're going to do is talk about how we make the most of free and open source software and why that is. Now, personally, I think that we've seen an incredible growth. This is a figure I put up in my speech yesterday. I gave a speech to companies. We've seen incredible growth. This is a new field. It started in 1984, and it's already worth $50 billion. That's quite astounding when you consider that it is competing directly with many other approaches to software, the best known being the proprietary approach utilized by companies in the desktop server and workstation markets traditionally. $50 billion market means that it's large enough, significant enough to attract investment from governments and from businesses literally around the world. It's a global phenomenon. That's almost one of our first problems in dealing with it, because when you have something global, you have so many different cultures, so many different languages, so many different approaches to doing business, approaches to organizing development, approaches to understanding what is valuable in society, that it's hard to explain it consistently. But the basic principle of this free and open source software is the same everywhere. The basic principle, the reason that it's worth $50 billion, applies uniformly across the world. It's the most flexible, the most adaptable, and most useful way of using software. No matter who you are or what you want to do, if it involves software, you will eventually find that this approach is the approach that allows you to do more. That's why it works. That's why it's important. The concept of having a shared platform that we build on, this basic principle and the flexibility to allow that has proven of value to everyone. The reason is simple, but it's not what people always perceive. This is where the term open source can occasionally be confusing. Open source is actually a marketing term invented in 1998 to describe free software. At the point where the development and adoption of free software was about to become large scale in the business environment. In the United States of America, there was a perception that the term free software would confuse people, presumably because quite a few Americans have very little education and don't understand that free means freedom rather than not worth anything. I'm from the British Isles. So the thing is that open source was used to explain to managers who didn't really understand the complexities of dealing with mathematical creative work, explain to them that if you could see the building blocks of the code, you could get more value out of the code. The term open source was the term that was used to give them that idea, that the source code, the basis of the software, was open to everyone. And that was a good thing. So basically, the term free software was the term we originally applied to this approach to software. The term open source was a term applied to it quite a bit later, at the point where it was becoming adopted by business. And the purpose of the term open source was to accelerate adoption, which it did. It did accelerate adoption. Though the issue with the term source code, open source, is that it does focus on source code, and that's actually irrelevant. That's not our key question. The key question and the value proposition of free software, or open source, or free and open source software, or FOSS, or FLOSS, or whatever you call it, the key value proposition is not whether you can see source code. That's simply a consequence. It's not the point. The point is, what can you do with the code? What can you do with it? Proprietary code, which was the dominant approach to software previous to free software's rise, proprietary code allows you to use it. You can use it with the permission of the creator. That allows you to do quite a lot. It allows problem solving and applications to be utilized. However, it's possible to do a lot more with software, and that's where free and open source software became important. Because instead of saying you could use software, instead of having a proprietary approach, the basic approach in free and open source software is that you can use it, you can study it, you can share it, and you can improve it. And you can do that without needing to get any further permission or clearance. In other words, the basic proposition is that you give the users the ability to do more. That's an important point. That's an important point, because people get bogged down, they get stuck on issues like source code. Forget about it. That's not the point. That's the point. Previously, proprietary software, you could use it. Free and open source software, you can use, study, share, and improve. It doesn't take a genius to work out that having that list of things gives more potential than use alone. These grants of potential, this ability to allow people to do so much, is codified. It's provided by licenses. They are giving you the freedom and flexibility to use, study, share, and improve in a formal way that means that you actually have that freedom in a certainty, in a way that can be proven in a court of law. This is important because in areas like research, for instance, in the 1970s, people would often have access to a great deal of technology, and they would do a great deal of things with it, such as improving it and sharing it. But they wouldn't necessarily have any right to do that. They wouldn't have a license to do that. The genius of free software is that it gives you a specific legal right to do so much with the code. And that right is framed in such a way that you never have to ask anyone for permission to do it. Now, if we're talking about rights, we're talking about licenses. And that's the exciting part of the talk. There's many types of license in the world. And if you start to search around for licenses that match free software or open source or free and open source software terms, you're going to find a lot. The Open Source Initiative has got, I believe, over 70 licenses which match their open source definition. The Free Software Foundation produced the most popular and most, I suppose, known licenses, such as the GNU GPL and the GNU Lesser GPL. The wider world produces innumerable licenses. I remember speaking with someone from Black Duck who told me that they had hits on over 10,000 licenses that claimed to be free and open source software. That's phenomenal. However, just as the basic principle is simple, the actual categories of licenses are less complex than it might seem. There's 4 categories. There's permissive, weak copyleft, strong copyleft, and network copyleft. This is important if you want to contextualize the scope of free and open source software. The basic principle is that any of these types of license allows you to use, study, share, and improve the code. The most basic one is permissive, which allows you to use, study, share, and improve the code, and basically doesn't say anything else. That's all it does. Then you have kind of basic grant of use, study, share, and improve, and something else called copyleft, which is not free software. It's not free software. It's not actually tied to code at all. It's much more about an approach to maintaining the license grant in the future. Copyleft says that basically the license grant applies to you and every subsequent user of that code forever. That specific grant means that if you use the code, if you use it in a context and put it into that context, then in the new context, the code still maintains the right for future users to use, study, share, and improve it. It's a detail. It's a bit of a technical detail, but it's important because if you're given a permissive license, which says you can use this code for pretty much anything, you can study it, share it, improve it, whatever, then you can put it into something. And you can put it into the new thing in such a way that the freedoms almost vanish. An example would be the Apple Mac OS X operating system. That's pretty much free software all the way through on the base. It's the Mach microkernel, and it's free BSD. Those are all permissive, licensed code. So Apple was able to use them, apply them to products, and ship the products. Because there was no copyleft, Apple does not have to give the same rights to the users of the code. Copyleft is about saying that if you use it, ship it, then the next person can also reuse it and reship it. With weak copyleft, you say that that specific grant stays with this piece of code alone. If you combine the code with other stuff, if you link it, well, the original code, it maintains the same grant forever for all users. The linked code, it doesn't. Examples of licenses like that, well, the key example would be the GNU Lesser GPL. Then there's strong copyleft. And strong copyleft says that if you use the code, if you put it in something and share it, then everyone in the future gets the same right on the code. Plus, if you link anything to it, if you connect anything to it, then that thing must also be under a compatible license and give the same freedoms to everyone. So we're seeing a picture here of code that you can use freely, code that you can use freely and all subsequent users must be able to use freely. Code that you can use freely and all subsequent users must be able to use freely, plus combined code must have the same terms. And finally, network copyleft that says all of that plus if it's on the network, if you share it on the network, then people get the same rights. That's a new category. It's a little bit of a confusing category because it's not traditional distribution. But it's emerging and it's growing. There's a license called the Affero GPL, which you might have heard of. The Affero is the first network copyleft license that has strong copyleft plus a network provision. It says you can use, study, share, and improve this code. Everyone else must always have the same right. If you combine code, it must have the same terms. Plus, finally, if you put the code on the internet to offer services, then you must offer the same freedoms to users. If you have a web service using a network copyleft code, then it has to have things like a link to download the source code, so any user can download the network technology and reapply it. That's kind of the scope of free software licensing. All based on the same principle: use, study, share, and improve. And then applying increasingly more terms to ensure that the basic grant maintains in the future for everyone in any context. Examples of licenses: weak copyleft, the LGPL, the lesser GPL. Strong copyleft, the GPL, that's a strong copyleft license. Network copyleft, Affero GPL. And of course, if you want a permissive license, the most famous one is the modified BSD. That's what you find in Apple code, mostly. Anyway, licenses are incredibly boring. And they're not actually important, except that they allow us to do deals. What's important is that each of the different types of license allows collaboration. Each of these licenses allows people to work together. And that collaboration drives growth. The licenses provide formal rules, and we can build on those rules to cooperate, even if we don't know each other and we don't trust each other. That's especially important in a global economy, because basically we have no idea what each other's assumptions are going to be. So the licenses provide the rules for our game. Then we play the game through collaborating, and if we do it right, we get something good. That's the principle. The 4 types of license I just mentioned, people choose whatever flavor makes them happy. Some people, they're happy with permissive licensing. I mean, the FreeBSD guys, whose code makes up a lot of the core of Apple OS X, they are perfectly happy with their license, and they did great. And a lot of their technology is doing amazing things all over the world. By the same token, Linus, who uses the GPL on the Linux kernel, well, he's pretty happy with his choice. He didn't always like the suggested upgrades to the future GPL, but he's happy with his specific choice today. People choose whatever license they want in free software to make them happy, to suit their project, to suit their market, whatever. They're just choosing a set of rules. A set of rules with the basic principle that we want to use, study, share, and improve. And that allows the collaboration. That's where the sharing happens, and that's maybe the most important part of all of this, the sharing, so that we can share brain power. So, here's how it works. You get third-party code, you contribute code, everyone gets value. That's the principle. That's why we want to use study, share, and improve. Because you get a ton of work by other people who are usually smart, and you give back work as part of your payment, and what happens is everyone gets more and more. It's a very simple principle. As we'd say in places like Ireland, it's one of those things you learn in kindergarten. It's play school stuff. You work together, you get more done. Though at some points in areas like the technology industry, we've lost sight of that. Perhaps due to the extremes of investor-driven marketing in the United States, where the focus of technological development was during the 70s and 80s. The idea, on the other extreme, is that you take as much as you can, keep it as secret as possible, and get as much money as you can. Sounds great in principle. It's a very short-term view, because a limited group of people have a limited ability to build stuff. And in a world with 6.6 billion people, other people are going to make competitive products against you. Collaboration in something that's creative and complex like software tends to produce more consistent long-term results. And that's what this is about. This is about producing consistent and useful long-term results. You get third-party innovation, thought, experience, and ability. You give back what innovation, experience, and ability you have, and that combined product is much greater than the individuals could make on their own. That's why it works. And of course, when you have an environment of sharing to do more together, there's good and there's bad. There's a lot of benefit, but there's also responsibilities. So, you know, it means you're sharing not just pure advances. You're sharing things like risks. You're sharing concerns. You don't get this for zero cost. That's an interesting point as well. Just like the term source code, people often think that because you can share free software freely, it means it has zero cost. Nothing could be further from the truth. There has never been, there never will be, anything in this entire world of any value whatsoever that has no cost or consequence. When it comes to something like complex mathematical constructions, there is an immense cost. There is an immense cost in terms of labor. And this labor has a huge amount of value. In the European Union, actually we valued aspects of free software labor because the European Commission was curious as to what this crazy new thing was actually worth. And the Linux kernel was valued at over 800 million euro. That was in 2007. Sharing to build something valuable means that you regard the thing as valuable, you take responsibility, and you deal with things like your responsibility to contribute effectively and sincerely to the value, and your responsibility as a co-owner, as a stakeholder, to take some of the potential risk of anything, risk of license issues, risk of failure, whatever the risk is, you take part of that as part of the cost of all of the benefit you are receiving. And when we speak about risk, we want to talk about problems. These are a couple of slides I put up yesterday as well. Basically, you do get problems with free software, open source, whatever you want to call it. You do get problems. And these problems have pretty simple reasons. People don't read the licenses, people don't follow the licenses. These are the basic roots of all the problems we ever see. And those problems however you formulate them, whether you formulate them as I'm a supplier and someone like Harold Velte in Germany is trying to sue me through gplviolations.org, why am I suffering like this? Or you're worried because you're a developer and you're trying to use something that looks amazing, but you're not sure if it's legally sound, you're not sure if it can work in your university, whatever. All of these problems have the same root. That people are not reading the licenses correctly and they're not following them. So the solutions are that you read the licenses and you follow the licenses. That's basically how you solve all of the concerns and all of the worries and a huge amount of the risk involved with free and open source software. It's no big deal. The details, of course, are difficult. Reading a license is no trivial task, especially if it's not in your own language. And following a license, just yourself, not too difficult. In a supply chain with many, many companies, or in a research environment with dozens of researchers, can be difficult. One person copies and pastes the wrong thing without checking what is under, what license it uses, and suddenly you could have a problem. That's true. Of course, that's true for anything. I mean, you just try copying and pasting Microsoft's code into your research project and see what happens. So basically, you should read licenses anywhere, whether it's free software or proprietary software. And when you're getting practical about dealing with free software, you just think about the context in which it works. This is a collaborative environment. It's all about working together. So you build relationships. You tell people honestly about what you're doing. Wherever possible, especially as this is global, you avoid politics. I'm maybe not representing everyone in the advocacy side of the community when I say that. But the simple fact is that across the world there are different perspectives about what is right and wrong. There are different perspectives about what is important. So people feeling very strongly about certain political aspects in one country, it doesn't necessarily translate into another country. Applying that to software doesn't necessarily always translate effectively. What is important is that this stuff is valuable because it allows us to do more with software and it allows us to work together in a way that is beneficial. So, be honest about what you're doing, stick to facts, and learn from major successful projects. You know, things like the Linux kernel are a great example. If you have a look at the contributors to the Linux kernel, you'll see a huge list of people from all over the world working together on this. People from large companies, research institutes, people from small companies, crazy individuals, the whole range. The norms behind managing that are valuable. And these norms have nothing to do with software code. These norms have nothing to do with licenses either. It's much more about global sociology. These major projects are a great case study in how you can get lots of totally different people working together relatively happily on a common shared interest. So to begin effective work in free software, what you need to do is just really know what you want, tell people what you want, stick to the facts, and learn from other people's experience in succeeding. These are not really complex principles, but it's important to highlight that this is how you do it. So we are sharing. We're sharing platforms. And that means that what you got to do is basically you got to understand how you can communicate what you're going to bring to the table, what you're going to take away from the table. So you work out how you can describe your requirements, how you can build partnerships, all about communication. And there are issues for this, and Taiwan, I think, is a country which faces issues in this area. I was talking with figures in Korea, and I was talking with a representative of a very major corporation in Korea, and he said, you know, we're doing a lot of work on products, a lot of work on things like the Linux kernel, and we have a huge problem with trying to work out how to get it back out into the global community. He said, the problem is that our engineers actually working on this don't speak any English, but most of the major projects like the Linux kernel operate in English. And on top of that, the engineers are not comfortable with the occasional conflictual environment in places like the Linux kernel. So for instance, in the Linux kernel, if you submit a bad patch, someone could tell you in a very vocal way that it's the worst thing they've ever seen. Did you ever graduate from college? Why are you even here? Something like that. And that was a problem. That was a problem. He said that this was a big, big, huge sticking block. Big sticking block. How do we put this code back into the world? Partly a contribution thing, but also partly business. Because for them to maintain all the code on their own costs resources. To share maintaining the code would save resources. Yeah. So you're sharing platforms, and you have to describe your requirements and build partnerships. And it's not always trivial. It's not easy. It's not easy. The ideal situation is probably if you need to work on a shared English language project, find a partner who speaks your language and English. Now that's an interesting thing. There's some amazing companies in Taiwan who operate very effectively, both in their native language and in English, and are doing pretty well in contributing back to the global community. I think that given how free and open source software works, partnerships, friendly partnerships between companies to collaborate on the shared platforms actually are very effective and very normal. Bear in mind, what we're looking at is a situation where the more people who work together, the more value for everyone. So you have to negotiate that. You have to think smart. There's no general rule for how to do it, though. It depends on your context. Somewhere like Ireland, basically, that's my own country, Ireland, you get the American companies, and you chat with them, and they help you. And then you criticize their lack of culture or something. And they still help you because they're nice. Anyway, the second big challenge, beyond communication, beyond dealing with engaging with the principle of shared platforms, is dealing with the community. The community doesn't exist. There's no such thing. But it still yells at you all the time. Basically, free software has got tens of thousands of participants of all types. As I said, individuals, research institutes, businesses, whatever. And all of these participants are out there. They're all stakeholders. They all have an investment. And they can all get really upset if you step on their toes, if you make mistakes. Dealing with that is not dealing with licenses. Licenses form the basis of the transaction. But beyond the very basics of this relationship, there's this large group of stakeholders. Communicating with them, working with them, goes beyond a simple set of formal statements. It's literally a long-term relationship with thousands and thousands of people. How do you deal with that? Well, the first step is the licenses are only the basis, but they are the most important single foundation of how this works. So you have to follow the licenses and the contracts. That's just a given. That's what you must do. Then you have to do things like consider the fact that this is about collaboration. You take something of value, you give something of value. That means you should contribute code back to projects. If you take code, if you modify it, and if it's really useful, then spend a little bit of time to work out how to give it back to the project. That's probably one of the key early adopter mistakes. A lot of people, when they start using this approach to software, they think it's a party because they can just get anything they want without asking anyone. And they do it. And then they wonder why no one is actually really paying any attention to their requirements or their products or what they want in the future. Simple answer is, if all you do is take, fact, people might even spend time trying to be unhelpful towards you. The opposite, if you take and give back what you can, even if it's small, give back something, then people will like to work with you. They'll understand that you get it, that you want to be part of this collaboration of sharing and working together. And another thing is to support the development of new code. There's lots of ways you can do that. One way is simply teaching people how to do it. And that's valuable. That's regarded as really valuable. If you teach one of your engineers how to develop free software, if you teach one of your friends how to do it, then that's regarded as a valuable service. And everyone feels, well, that's great. You're adding one more brain to the pool. That pool is creating the future. Support the development of new code. Teach people, donate money to projects, whatever. Do something to show that you appreciate that there's hundreds and hundreds and hundreds and hundreds of millions of dollars of code being given to you by other people. Now, my favorite part. The Western experience. I live in Japan. I'm a prisoner there. I was kidnapped by my wife. And everyone says Western in Japan. And it's fascinating to me because I'm Irish, and the nearest country is Britain, and they've been our enemies for 700 years. And the very idea that there's a unified West where, you know, the English and the Germans and the French and the Irish and the Americans and presumably even the Canadians all think the same is fascinating to me. It's an amazing idea. It's a bit like saying that all of Africa and Asia gets along and thinks the same thing. But anyway, if we were to say, what happened in Europe and the Americas? What was the Western experience since 1984 in free software and open source? Basically, after we finished our disagreements about how to say tomato and tomato, or aluminium and aluminum, after we finished that, what would we agree on about free software or open source? This is pretty much it. Basically, this allows collaboration. This approach to software allows collaboration. Number one point. Immediately after that is the second important thing, that barriers to collaboration reduce benefits. In other words, we have found that collaboration on software provides a benefit. That collaboration on software, just that, provides benefit no matter what you do in software. And therefore, any barrier to collaboration reduces benefit, reduces potential. That's what we found. And therefore, we need to talk more. We need to work together more. The reason that free software succeeded is not because it's morally right. It's not because of any political view. The reason it succeeded is that it does something. It does something with software that allows everyone to get more, no matter who they are, no matter what they want. This allows them to do more. So collaboration works in software. Barriers to collaboration do not work. We need to collaborate. That means we need to talk more. That is the Western experience. So, the expectations. This is a slide I showed yesterday, and it's just as valid today. The expectations when you use free and open source software are here. That people are going to follow the licenses, people are going to collaborate, people are going to recognize that the field has value. These are the expectations that are out there. And basically, if you don't understand these expectations, you're going to upset people. one way or another. These are the basis of what every participant who's been in the field for any period of time thinks. They will think a lot of other stuff. Some people will think that, for instance, you must use permissive licenses, or you must use strong copyleft licenses, or any number of extra details. That's not necessarily the key. Those are individual perspectives and individual applications. If you're generalizing about what does pretty much everyone think, there. You're going to follow the licenses, you're going to collaborate, you're going to recognize that this is valuable. It's not valueless. That's kind of another important point based off the idea of this thing having no cost. It's very annoying to a developer or a multinational corporation that spent billions of dollars on this technology when people regard it as valueless. Important point, important point. Huge value, massive value. This is the first field, the first time we are seeing active global collaboration on one thing, regardless of language, regardless of use, regardless of who or what or where. Huge value. One of the most valuable things we've ever done as a species. But let's bring it back down. What does it all mean? What does it all mean in practice? And I'm going to run through some kind of business-oriented things here. Because whether you are in business or not, the numbers behind free software indicate that business is critical. The numbers that are being quoted to me nowadays are that between 70 and 80% of all development on key projects like the Linux kernel is corporate funded. In other words, it's not actually academics or researchers or individuals who make up the majority of work in this field. The majority of work in this field that allows everyone, anywhere, to use, study, share, and improve, the majority of work is directly paid for by profit-orientated entities, mainly multinational corporations. Because for them, this has huge value too. And they will spend money to give everyone the technology because it still drives even more value back. What that means, though, is that you need to be really aware of the kind of commercial imperatives around free software. Because if you're not, you won't understand what's happening day to day. Bear in mind that its primary use is out there in the marketplace. It's not a research thing. It's not a thing which is used exclusively in a non-profit environment. This is primarily what powers all of the computers, what will power all of the cars and all of the planes and all of the trains. This is going to be the basis of the digital future. So, you got to think about it. And that means you got to think about things like supply chains. How does it all work? Why does it work? It becomes important because people will bring it up in discussion and it'll get confusing. But it's still simple. It's all about collaboration. It's all about responsibility. It's all about just being sincere and dealing with this. If there's loads of people working together, if there's loads of people moving things hand to hand, sometimes improving it, sometimes just shifting it on, then it's all about agreeing who gets risk, who gets danger, who's distributing, because distribution is where the license kicks in. If I give it to you, I have to give you the freedoms. And be able to record and audit what's going on, knowing who did what and where. That's where my little comment earlier about a researcher who copies and pastes code and that being a disaster comes in. If anyone ignores a license and puts code in the wrong place, then somewhere, sometime in the future, that can cause a problem. And who knows where that problem will appear. It's bizarre what you see Global collaboration is fascinating. I've worked on the compliance side with gplviolations.org, and it's been amazing chasing back the root of issues. All of these hops in the chain, there's companies, there's research institutes that helped build the technology and they never checked what was being released. Then there's individuals who just sent in an adaptation which they might have taken from somewhere else and forgotten to include the license. It's amazing when you dig down how a collaborative environment can lead to chaos if people don't write down what they're doing. The Linux kernel, actually, if you want to have a look at the Linux kernel project, is genius in managing this. They are brilliant. They have a very simple method of whenever something new comes in, different people basically sign. I saw this, it makes sense. I also saw this, it makes sense. And that audit chain means that if something goes wrong, in a few moments you're able to check out what idiot messed up today. So, using code, and the fundamentals are pretty simple. You know, using code, you have to know what you can work with, you have to know what you can't work with, and you have to know what to do when something completely different appears. Remember earlier when I said there were like 10,000 licenses? I wasn't kidding. There's huge amounts of variance, and you have to think about that. So one way to do it, this business thing, is to have a simple method of knowing that if it falls into something that you understand, you just use it. You run with it. That's okay. If it falls into something that you understand but don't like, you reject it immediately. You don't think about it too much. You just say, well, I know I can't use this. It's got the wrong license. I'll throw it away. And if it's completely unknown, if it's really weird, well, if you're a business, you send it to your legal department. This is a chart created by Royal Philips Electronics, a nice Dutch company that makes televisions and razors and medical equipment. If you're an individual or a project and you have a problem with something completely weird, well, then you would be stuck, except that we're in a collaborative environment. And you can just go to anyone else, any other project, any non-profit organization like Free Software Foundation Europe, and you just say to them, what is this? And they'll help you out, because you're neighbors. You're working in the same field. And touching on a very important issue, and I'm aware time is a little tight. Don't worry. I've got 10 minutes extra before Florence hits me. Okay. Coming right out of all of this process management, about allocating risk, about recording where things are from, about knowing what you can use, what you can't use, and where to go if you're confused, is the idea of problems being fixed. And I want to cover this because fixing problems with third-party code sounds daunting, especially when the third-party code is worth so much. Whether it's in research or it's in business, we have found that people keep saying, the uncertainty bothers me. It means that I have difficulty using this. It's funny because when you look at the value of this $50 billion economy, when you look at the direct value of something like the Linux kernel at over 800 million euro, then count the lawsuits and count the costs. Tiny. This global collaborative environment has far less risk and cost than proprietary software, precisely because it's about collaboration. You must follow the licenses. That's not negotiable. But if you're following the licenses, and if mistakes happen, this is not a field where people immediately think, let's punish you as much as possible. Let's take this opportunity to take all of your money. Let's crush you. That's not the first thought, because the first thought is that you're not collaborating properly. That has to be fixed. That's the first thought. And if you want to collaborate, if you actually made a mistake, or if it was unknown to you, and you're willing to learn, then people are going to help you fix the issue, not spend their time causing extreme pain. In other words, free software, open source, when it comes to technology, licensing, and risk, it has a different form of risk. It has a different form of penalty. if you are willing to collaborate and willing to work together, then people will help you rather than hinder you. What you have to do is to resolve any problem thinking about the fact this is a collaborative environment. You have to accept reports of issues, investigate, and communicate with the people who reported it. This isn't about hiding like you would in a traditional situation. This is about saying, is there a mistake? I'm a collaborator. These are my colleagues and stakeholders in this telling me I made a mistake. And working with them to find out what it is and then fixing the problem. This is completely different. This is an environment where multinational companies will get an individual reporting a problem, and the multinational company will talk to the individual to isolate the issue and then explain what they're doing to fix it. It's about collaboration and working together. And if you use that mindset to resolve problems, if you use that mindset, you'll find that it's a very, very, I wouldn't say forgiving, but a very, very open environment to accepting that you're there to learn. You're doing your best. And when you need help, people will assist you. That's why risk, containment, and engaging with this is different to proprietary software. And why when people suggest it has more risk, I tell them, go look at the numbers. Go look at the numbers of how many lawsuits there are around small amounts of proprietary code, and how many lawsuits there are around full-stack free software solutions in a competitive global environment. Then compare. So, yeah, I didn't steal Apple's trademark. It's got 2 extra letters at the back. You've got to think differently. Correct grammar. You've got to think differently. This approach to software is different to proprietary software. It's an environment where your competitors are your stakeholders. You are working together with the same people you are trying to beat in the market. Because you're smart, you guys have worked out where you're really competing. And you've worked out that that's the 2% over here, and the other 98% we're going to collaborate on to reduce cost and accelerate innovation. Now that's thinking differently. And that's why free software is really winning on all fronts. Fascinatingly, your customers can become suppliers. That never really happened before. But quite seriously, if you have a Linux kernel-based television, and if there's a bug, well, you know, someone might fix the bug and email it back to you with a correction. Everyone can use, study, share, and improve. Anyone, anywhere, can change the focus of their relationship with you for any reason. If you understand that, if you work openly with people, if you're ready for dealing with that, fascinating things happen. By the way, when I said that a customer could become a supplier and send in a bug for a television, that's not a joke. I know that that has happened. It's amazing what happens when anyone, anywhere can participate. You won't get uniform participation, but you will get the most unexpected participation and contributions. And if you're smart, if you're able to deal with working with people, you will find out that people's ability to create, to collaborate, really offers tangible benefits. So when you're looking at free software open source, what you're looking at are basically 3 steps of keeping it very simple. Because we're dealing with a global environment, it's very easy to get confused on details. Whether these details are politics, regional business norms, whatever, it's very easy to get confused. So don't. Go right back to the fundamentals. Remember that it's about using, studying, sharing, improving. Stick to that. Stick to the licenses. Keep it focused. Share alike. You know, that's related to play fair. Share alike. If you take something, give something back. And play fair. If you mess up, own up to it. You know, these people aren't your enemies. These people are your collaborators. They are, in effect, your co-workers that you've never met and will never meet, and you don't even know their names. But they're there. They built the technologies that are powering your cell phones. And they're happy to respond to your emails because they think you have value too. So basically, those are the steps to succeeding in this. And that applies whether it's about business or research or whatever. If you live in a walled garden of secrets, then you're not going to be collaborating with all those people out there. If you open up, say what you want to do, and try to work together, that's where amazing things happen. So, back to play school almost. You know, we all gain by sharing. There are rules to follow, and if you have a problem, you can talk it through and fix it. Those are the fundamentals of free software. In a way, free software encapsulates one of the pure expressions of how people can work together. We've applied the simplest principles of working together to software, to mathematical creation. And we found that it really, really worked. So that's it. That's all it is. You don't have to worry too much about the nuances of business, about the nuances of licensing, about the politics and the different perspectives and the different conflicts around the world. Those are inevitable. In the same way that humans can be kind to each other, humans can be cruel to each other, and people all have different opinions and will bicker. Not the key point. These are the key points. We all gain by sharing. We can share if we have rules, so we all know it's fair. And if there's a problem, we can talk it through. So free software, we use, study, share, and improve software. We have 4 types of license to help us do that. And basically that's it. That's all there is to it. There are various resources around the world to deal with the details. On my own company website, opendawn.com/resources, there's a few resources, including links to a lot of reading material that I personally found useful when I've been working in this field. And, oops, skip the slide, there you go. Just like everyone else in this field, I'm happy to talk. You can email me with any questions or comments, whatever. If you've got a project where you want help, if you're confused about a license, whatever you've got, email me. Odds are, because I'm not actually very smart, I won't be able to answer you. But I will tell you exactly where to go to get the sensible and right answer from people. So that's it, ladies and gentlemen. Thank you very much for the chance to talk about this field. I do appreciate it. And if there's one thing I'd like you to take away today, it's that this field is not about the confusion of noise on the internet that you see when you type these terms into Google. This field is about us looking at these computers and working out how we can do the most with them. We've found that out now. We know the answer. It's this. This is how we do the most. And every single person in this room can be part of it. Everyone is welcome. What we would love to see happen is for more bridges to be built between Europe and Asia and America, Africa, and wherever else we can build bridges. And to build a collaboration up, to get as many of these 6.6 billion minds working together on these problems, because we have really found huge benefit in doing that that applies to everyone. Thank you all, and I'm going to be here for Q&A in a little while.